Hey guys, today we're going to be looking at proportional and non-proportional relationships. Remember, for a proportional relationship, it must have a y-intercept of 0 or cross through the origin of 0, 0, and it must have a consistent rate of change or slope, which would mean linear or straight line. Let's look at these and let's understand why these relationships are proportional or are not proportional. This graph here on the left is proportional. It makes a straight line and it crosses through the origin at 0, 0. The graph to the right is not proportional. Even though it does make a straight line, it is linear. In fact, this slope would be 0 because it's horizontal. However, the y-intercept is not at the origin. It's crossing below the origin, which would be a negative y-intercept. Now for a table, remember we have to figure out what the constant of proportionality is, which is y over x, to decide is this a proportional relationship or not. Let's try the table on the left. And so if we do y over x, which would be for the first one 1 over 5, and then divide first number in, last number out. 5 does not go into 1, add a decimal and a 0. 5 does go into 10 2 times. We should be getting 0.2 every single time. If we get 0.2 every single time, then this will be a proportional relationship. Let's look at 8 over 40. And do first number in, last number out. 40 does not go into 8, add a decimal and a 0. 40 does go into 80 2 times. So again, we're getting 0.2. Let's look at 13 over 65. 13 in, 65 out. 65 does not go into 13, add a decimal and a 0. 65 does go into 130 2 times. Now you need to keep checking the whole entire table. To save time, I'm going to stop here and I'm going to say yes, this works out every single time. Every single time that we divide, we would get a constant of 0.2. Now let's look at the other side. Y over x. So this will be 30 over 2. And then if we divide, 30 goes in, 2 goes out. 2 goes into 30 15 times evenly. So we would need to get a 15 every single time that we divide. Let's try the next one. So y over x, 90 over 8. And divide first number in, last number out. 8 goes into 9 one time. Minus 8 will be 1. Bring a 0 down. 8 goes into 10 once. Minus 8 is 2. Add a decimal. Bring a 0 down. 8 goes into 20 twice. And I'm going to stop right here. I'm noticing that these two numbers that we got 15 and then we got 11.2. They are not consistent already, so I don't have to check the table. So this right here is how we know this is not proportional. So we did not get the same constant. Okay, let's look at the equations. Both of these are proportional. I know that these are proportional because y equals 3x is in the format of y equals kx, and that means that we have a y-intercept of 0. So it does not have to have a plus 0 on the end. Now this one does. Both of these are proportional. They have a slope of 3 or -2, and then they have a y-intercept of 0. Even though there's not a plus 0 on the end of this 3x, it is still going through the origin. Now this one, y equals -4x minus 5, is not proportional because of this -5 right here. That's a y-intercept of -5, and remember, it has to go through the origin. So again, the y-intercept must go through the origin at 0, 0. Okay guys, that's comparing proportional with non-proportional relationships. Remember, proportional must go through the origin at 0, 0, and then it must have a linear or a straight line. Thanks for watching.